the fundamental theorem of algebra. When talking about zeros, we could look at the graph and say, oh, look it, there's 2 zeros, or look it, there's 1 0 that happens twice, or oh, there's no real solutions. But what if we had a larger degree and it still looked like this? What if this was a degree of 6? What if this was a degree of 8? We don't really know. So when we're talking about zeros, there are multiple different things that could show up. When we look at the fundamental theorem of algebra, I've talked about this in class, but the degree will tell you about how many roots you have. So we know that this problem, so we're looking at problem 1, we know that this is going to have 5 zeros. Some of them may repeat. What we have to do here, because we're not going to be able to factor that. However, we can plug this into a graphing calculator, into y equals, we're going to go to the table. So second graph to table. One thing I know is that where it crosses, where y is equal to 0, so right here, that means that that's a solution. That's where it crosses the x-axis. So I'm going to write down that x is equal to -2 because that shows it up on my graph right there. Bam. I'm going to keep on going down. Oh, here's where y is 0, so x is going to be 1. Here is where y is 0, so x will be 2. Are there any others? And really, you should just look in between -10 and 10. And that's what I have. So I know 3 answers. So I have to figure out the other 2. I don't know if they're real. I don't know if they're going to be radical. So what I have to do is divide. I'm going to synthetically divide because I already have the 0 here. So these are my zeros. So I'm going to synthetically divide to see what I have left. I'm going to divide out my -2 first. So again, if I were to write out this equation, that's x plus 2. So when I put in the box, I put the 0. So I have a 1 for x to the 5th, and -1 to x to the 4th, and -3 to x cubed, 3x squared, -4x, and 4. Draw my line. So I'm dividing up my -2. So I should have no remainder because this is a 0. So bring down the 1. Multiply, add together, multiply, add together, multiply, add together, multiply, add together, and multiply, add together. So that was 1 0. So I factored this one out. Now I'm going to factor out my 1. So I can go off of this problem right here. So now I'm going to factor out my 1. So bring down the 1. So I have 1. 1 times 1 is 1. Add together, multiply, add, multiply, add, multiply, add. So now I took out 2 of them. So now I'm also going to take out my last 0 here. So 2, bring down, 1, 2, add, 0, 1, 2. Now I have to figure out what I have left. So I'm looking at this. When you're factoring something out, you're taking out a degree. So I started with x to the 5th. I took out a degree, so this was x to the 4th. I took out a degree, this was x to the 3rd. I took out a degree, so this is x squared. Now what I have left is x squared plus 0x plus 1. So now my overall answer, now I have to continue solving this. Now this will always change. Either I could factor it, quadratic formula, or I can just solve. In this case, because I have the number, I can go x squared plus 1 is equal to 0. I can solve that equation. So I'm going to subtract over my 1, and then I'm going to take the square root of that. Remember, this is positive, negative, and the square root of -1 is I. So my overall final answer, I should have 5. I got 3 from my calculator, and I got 2 from solving. See, that was fun for the fundamental theorem. So if for some reason the problem is not given to you in standard form, that's the first thing you should do. So I'm going to have my x to the 4th plus 2x cubed. I'm going to subtract my 13x squared. I'm going to add my 10x equals 0. So one thing I noticed right away, I can take out an x, leaving me with x cubed plus 2x squared minus 13x plus 10. I know that this answer right here, I'm going to already write down for my answer over here because I know that's going to be 0 because 1x by itself will be 0. So now I want you to pause the video and look to see if you can find the zeros on your calculator with this. You should have gotten that you got -5, 1, and 2. Again, you look where y is 0, you look at the x value when y is 0. So now if you divide those out, so pause the video and divide them out. Remember, this was x cubed. You divided out a degree. This was x squared. Divided out a degree. This is x. This is just a number. So I don't have any equation left over. Why? Because we found all four, remember if you look at the beginning, four zeros with our calculator. So now, again, I want you to first look at this problem. I want you to look at your quadratic, or type this into your equation and look for the zeros on your calculator. So you should have gotten 2 zeros from your calculator, negative 3 and 3. So again, first thing you want to do, because there should be a total of 4, is to synthetically divide those 2 zeros out. So I have a 1 in front of the x to the fourth, a 1 in front of the x cubed, negative 7 in front of x squared, negative 9 in front of x, and negative 18. So first factor out both of these zeros. So pause and factor those out. So this was x to the fourth. We factored out a 0. We factored out a degree. We factored out a 0. We factored out a degree. So what we have left now is x squared plus 1x plus 2 is equal to 0. We can't factor that any further. So this is now where I'm going to figure out what my last two answers would be by using the quadratic formula. So opposite b plus or minus the square root b squared minus 4 times a times c whole shebang over 2a. So negative 1 plus or minus the square root, this becomes negative 7 over 2. So my final answer would be x is equal to, we got negative 3 from the calculator, we got 3 from the calculator. I'm going to rewrite this equation. So it's going to be negative 1/2 plus or minus, when I have a square root of a negative, that becomes an I over 2. So here's 1, 2, and then here's one answer, and here's the other answer. So again, this whole number has to stay together. This number has to stay together. This is not by itself. This is not by itself. This number stays together. So I have 1, 2, 3, 4. I want you to try to do the last one by yourself, making sure when you synthetically divide, this is like saying plus 0x squared. You do not have the x squared there, so when you synthetically divide from your calculator first, and then check your answer with mine. So your overall answer should be x equals, you should have gotten 2 and negative 1 from your calculator, and you factored both those out, leaving with 2x squared minus 1x plus 3, and then using your quadratic formula, you should have got 1 over 4 plus I squared 23 over 4, and 1 over 4 minus I squared 23 over 4. And those have been your 1, 2, 3, 4 answers. See? What did I say? That was fun. Fundamental theorem of algebra. Have a great, grand, wonderful day.